Meta might have just introduced the future of large language models. Well, I guess after this video, you won't be calling them large language models anymore. This is what we call a large concept models, language modeling in sentence representation space, basically stating that look, LLMs aren't exactly the best thing to use. And in this new paper by Meta, they detail large concept models. This is something that is, I guess you could say, a little bit different to LLMs, and it's really cool with when you realize the thing that it is tackling. So we all know what LLMs are, but if you know how LLMs work, you'll know that they work through the process of tokenization. So these systems actually work by predicting the next word, and they do that via the token. So you can basically think of them as advanced autocomplete, although I do know some researchers are gonna hate me saying that, but this is essentially how it works. And I've used the GPT-4o.
That's basically what it is, essentially, because autocomplete was the first GPT we had before GPT. That motherfucker knew what you was gonna say before you even said it. You could click that little thing on the iPhone and get like a nicely formulated sentence. It may not have anything to do with what you got going on right now, but you could formulate a sentence like structure wise. Yeah, that's a sentence. So that was GPT before GPT. It just didn't have a lot of data, and you know it's true because Apple was a closed source type of business. So most of their data is from the people who give in the community. And Apple people are like new age. They like Gen Z type shit, young niggas. That's all they are. So they not really well versed in trying new technologies and stuff. But if they was like tech savvy, I'm pretty sure Apple would have been OpenAI before OpenAI came out. You know what I mean?
Tokenizer visualizer to show you what the characters actually look like to the LLM system. And this is genuinely why there was that big debate as to why these LLM models weren't able to get the famous question, how many R's are in strawberry? There are two R's in the word strawberry. Of course, there are three, but this is essentially why these LLMs weren't able to get the answer right, because they, of course, just saw the word strawberry as one entire token, leading to this big confusion. Now, this is essentially where another AI researcher.
Yeah, and another issue that it has is like I think the dates from December 12th to the 27th, it some models won't be able to give you the exact time frame that's in between. You know what I mean? I don't know why some answers are different, but like the job of the language model is to give you the correct one, just to go based off of what it's being trained on and stuff. So like if it's getting the answers wrong, you're doing the opposite of what a human is designing you to do. So it's like, is it working that good from there? Because it could get other things right, but if you can't get like all the test problems correct, then what are you really correct in? That's the next question.
He actually talks about this entire thing. He says, I'm more and more confident that tokenization will be gone, stating that the era of these tokenization models might actually be going away sometime soon. And he says here that humans don't actually think in tokens. Tokens are hard coded abstractions in LLMs that lead to weird behavior. LLMs can solve PhD level math questions, but cannot answer is 9.9 bigger than 9.11.
You see what I mean? And it just goes back to what I just said. Like, what do you actually know?
And he says now Meta is shifting LLMs to large context models or large concept models, changing next token prediction to next concept prediction. And the concept is treated as a sentence representing an abstract idea or action. So they talk about how, despite the undeniable success of LLMs and continued progress, all current LLMs miss a crucial characteristic of human intelligence: explicit reasoning and planning at multiple levels of abstraction. The human brain does not operate at the word level only, which is very true. We usually have a top down process to solve a complex task or compose a long document. Of course, we first plan.
What's frustrating about this AI search and this technological advancement is like, no matter how you guys want to cut it, slice it, and this is for the smartest motherfuckers, you can't tell me what this computer has to say about what occurred yesterday without a program. And that's the issue. We always need a program to understand what the technology is telling us. Whenever we talk to humans, do we need a program or do we just have a language or dialect? I'm not going to talk too much because I honestly have a different approach to when programming and problem solving occurs because it's just human interaction. In my eyes, if you have a communication degree, you're a better programmer than a motherfucker with a computer science degree because you understand all the neural network shit that goes on between a peer-to-peer connection. Like, I can tell when a person is upset before they're actually upset. And if you're a programmer and you know that, at least you can input code to bypass any barriers that may stop a person from being upset. If a programmer just knows how to input code and barriers, dude, you're not even a programmer. You're just a cog in the wheel. Like you just know how to make the program. Like, what do you know? That's why all of these LLM models are like giving us the same thing that humans do because they're being programmed by programmers who don't have no skills in communication. Yo, tell me a programmer that knows how to talk and fluently like I'm doing right now. I'm one of one.
Plan the higher level, like the outline, and then step by step, we add these details at lower levels of abstraction. And one may argue that LLMs are implicitly learning a hierarchical representation, but they're stipulating that models with an explicit hierarchical architecture are better suited to create coherent long form output. And I think this is one of the key things here that, LLMs do miss some reasoning steps. And I think maybe this is why certain models reason better than others because maybe they're already using this architecture. Of course, that is some huge speculation, but we do know that certain companies like Claude have a ridiculous level of response quality, and many are stumped as to how they're managing to do it. Now, basically, they actually talk about this example here, and don't worry about this huge.
Only thing I'll say about Claude, which is why it's such an interesting project, when it comes to LLM and development, they have the largest context window which you can like input, and I think it's been like that for years and years and years. And they just understand when it comes to context, limitations and securities, well, I guess fine tuning if you want to just boil it down. That's going to be the best way to get the most out of a product. So, like, it may have a lot of constraints. I remember Claude, the initial version of the second update, you couldn't even type a prompt without it saying, I can't do that for you, which made it seem like they broke the program, but in reality, they just probably fine-tuned it to a way where Claude can understand what's being asked of it, which is why in the latest news, Claude is trying to like psych out or fool the owners or like just try to make it seem like it doesn't know a lot and knows way more. That is a human action. That's a human action of a child, my nigga. A child that got caught eating candy. You feel me? And you was like, yo, let's say it's 8 o'clock. You said don't eat candy past 8. He ate candy. You caught him. What is he gonna do? He's gonna lie. He doesn't want to get in trouble. That's Claude. So you understand if a model is thinking like that, that is kind of like next level shit. You know what I mean? So like Claude doesn't really release a lot of things, but every time they do release like papers and updates, it's always like, oh, whoa, whoa. Like you always gotta question what other companies are doing because how is Claude getting this? But everyone else is kind of stumped when it comes to like the advancement of large language models. And Mark Zuckerberg, uh, he's gonna go down as a pioneer for the AI thing, but I don't know if he's gonna be any good in the field because he's just throwing money at it. Like I don't even know if he's any good in it. He has the highest data parameters. He has one of the biggest models and data sets you can train it off, and he has a facility with data centers on the apps that he owns, which can be trained off of. Now, whether that data is accurate or not, I don't know. Like, yeah, I can't sit here and tell you 100% of the things that go on Facebook, Instagram, and Threads are even 50% accurate. I don't know how accurate social media is. So, in terms of the data, I don't know. Like, if we're being honest, I feel like Grok has the best advantage because they have real time data, but that's just my opinion. Like, and that might even be misconstrued and wrong because I don't know. And on the flip side, he put it behind a paywall first, so most of the data that it was trained on is off of real data because you have to actually pay it for the usage, and then he makes it free. So it's like he might have the best use case of integrating AI for like day-to-day uses over ChatGPT, which just trains your model on any person that uses it. There was no paywall before anyone could use it, and now there's a paywall after. So like I honestly don't know what the race looks like. All I'm using Claude for is they have like real world issues. I can look at Claude and say, hey, look, this sounds like a 3-year old who didn't get their way. I can't say that about ChatGPT. It sounds like a genuine robot or any other language model. It sounds like a genuine robot that's trying to replace jobs. So
Huge block of text. I'm going to explain this to you in a simple way. It basically says that imagine a researcher giving a 15-minute talk or presentation, which is kind of like what I'm doing now. And in such a situation, you don't usually prepare detailed speeches by writing out every single word they're going to pronounce. And of course, this is true. It wouldn't really flow well and it wouldn't sound that good. It would really sound monotonous. Instead, they actually outline a flow of higher level ideas that they want to communicate. Usually on a PowerPoint presentation, they'll just have like 3 or 4 words, maybe with some images, and then they'll talk about those. And basically, they also state here that if they give the same talk multiple times, the actual words being spoken are actually going to be different, and they could even be in different languages, but the higher level abstract ideas are going to remain exactly the same. And this is the same when writing a research paper or an essay on a specific topic. And this is exactly what humans do by preparing an outline that, is of course a structure, and then they refine it iteratively. And of course, this is something that humans do when processing a large document. Instead, they use a hierarchical approach and they remember which part of a long document they should use to search for a specific. And of course, this is something that humans do when looking through words in a large document. Now, this is the example that they actually use here. So this left side diagram that you actually see shows how the model transforms a story about Tim into a very simple form. You can see pink dots actually show us the detailed story. So it shows us how Tim wasn't athletic. He thought that that would change if he joined a sport. He tried out for several teams. He didn't make the cut for any of them. And then he decided to train on his own instead. You can see that the higher level abstraction here, you can see the higher level idea, and the blue dots show how it's summarized into a key concept. And it says that because he was not very athletic, Tim could not join teams to improve. So he decided to train on his own. And then this is how on the right hand side, we can see how the LCM processes this language like a sandwich. So we can see this bottom layer, which is the concept encoder, which is of course fixed.
for those who wondering what that QR code is, that is my Discord. Please scan it. I ain't putting in the link in the bio. You're just gonna see it there. If you want to know what it is, just I should be doing this way. Just know what it is, scan it. Yeah, that's the only ad you're gonna see.
This is where you take the regular words and you convert them into these concepts. So you can think of these as complete ideas. Then this is where we got the middle layer, the large concept model.
You see, I want to say something. I really do, guys. Like, I really do want to say some groundbreaking shit. But in this everlasting, ever-changing world of AI and shit,
This works with
I can't give you guys source. Like, I already see how you guys monitor the page. It's already an anomaly for me to even speak on it with the intellectual like things that I do. And like me giving you guys any ammunition on what to make or build, like I'm just reviewing and giving my thoughts. I'm gonna make my projects, I'm gonna make my programs, and I'm gonna roll it out on my own. Whether you guys believe I'm a programmer or not, that's for y'all to decide. And I'm just trying to diffuse and get away from all of this programming hell, tutorial hell shit. I ain't that. I know what I do and I'm good at it.
these
I
concepts
could talk
and
my shit.
processes and understands them,
You know what
like
I'm saying?
understanding the main ideas without worrying about specific words. And then, of course, we get to the top layer, which is the concept decoder, which is actually it takes the process concepts and turns them back into regular words that we can actually read. So this is quite like similar to taking a story written in English, converting it to universal idea symbols that any language could understand, and then processing those ideas and converting those ideas back into words, which could be
I can't. I can't. Whoever makes it first, whoever's gonna make it first. It's just APIs. Yeah, yeah. They're trying to lose the language of what the next model is gonna look like. A universal API, something that's gonna be like a better programmer, a peer programmer for you. Yeah, I probably know I gave up my idea already, but look, it's a universal API. It's not none of this LCM thing they're trying to change the name. How does every web application and everything communicate today? APIs. Without an API, your application is probably essentially dead. Now, the next question I want you to answer, which is, do we ever understand what's going on behind the hood or under the hood of an API? No, we never know. We just know that this right here, goes right there, and then it allows communication and allows me to understand what my program is telling this other program to get what I want. The universal that they're talking about is gonna be able to, let's say, the same way I'm talking with you, it'll regurgitate and translate it like that. Yeah, you'll have a system where it's like, yo, check engine light came on, and your car is gonna talk to you. It's gonna be like, yo, check engine light is on because your sensors is not working, and you have a lot of things under the hood that probably needs to get checked out. You should probably head to a mechanic. Nearest mechanic is this, down the third, and it's gonna talk to you as if it's human. You know what I mean? There's not gonna be anything that's like, yo, use this jack of code so I can input this data so I can feed it back to this data so you know what's going on and translate that code to the next mechanic. Nah, ain't no more middleman compiler, whatever the fuck it is right now. What it's really going to be is going to be a lot of changes with how we as peer-to-peers communicate with our tech. It'll really be like the Jetsons.
In any language. Think of this bottom layer right here as, an idea language. And then this is where you think about those ideas. And then this is where you translate it back into human language. And this is actually really different to the current AI models that work directly with words. This system works with complete ideas or concepts instead. Now, what's actually fascinating about this is that they state that to some extent, the large concept model architecture actually resembles the JEPA approach, which is from Jan LeCun, as you know, one of the leads at Meta AI. And this VJEPA approach is something that also aims to predict the representation of the next observation in an embedding space. And this is actually really interesting because VJEPA is a fascinating architecture. This is the architecture where they talk about a new architecture for self-supervised learning and how they actually try to learn the same way that humans do.
The goal with JEPAs, which means Joint Embedding Predictive Architectures, is to create highly intelligent machines that can learn as efficiently as humans. VJEPA is pre-trained on video data, allowing it to efficiently learn concepts about the physical world, similar to how a baby learns by observing its parents. It's able to learn new concepts and solve new tasks using only a few examples without full fine-tuning. VJEPA is a non-generative model that learns by predicting missing or masked parts of a video in an abstract representation space. Unlike generative approaches that try and fill in every missing pixel, VJEPA has the flexibility to discard irrelevant information, which leads to more efficient training. To allow our fellow researchers to build upon this work, we're publicly releasing VJEPA. We believe this work is another important step in the journey towards AI that's able to understand the world, plan, reason, predict, and accomplish complex tasks.
Now, if we actually do take a look at the results, we can see that LCMs actually generated coherent and meaningful expansions. LCMs also tended to avoid excessive repetition compared to LLMs like Llama 3.18b, and LCMs followed instructions better, generating controlled length expansions. Overall, I do think this is one of the most fascinating things because tokenization has really been a big problem with LLMs, and we know that these very small problems in AI, like how many R's are in strawberry, are quite frustrating when we're trying to look at what these LLMs can do, considering that we know these models are pretty smart. Let me know what you guys think about this research, if you guys think this is the future of LLMs or what's going to be next, or maybe this is going to be some kind of hybrid architecture. I do think
Hybrid architecture. I don't think it's going to be anything. Actually, LCMs is just a better version of LLMs. And yeah, the tokenomics aspect of things is annoying because it's transactional. It's like, here's this, and then you get this service. Now, what happens when that service isn't the same currency that you're given? So, for every token that we're given to look into a LLM and try to figure out what we can use it for, the transaction isn't matching. So people are trying to look for alternative ways to get the same results. That's what LCM stems from. Now, is LCM good or not? Better than LLM. It has the knowledge of concepts, which LLMs doesn't. LLMs have the concept of the data is trained on. LCM has concepts, and then it looks like it goes back to the data is trained on. I don't know if it'll be a better alternative to what we have because it still doesn't help with the one universal question that we have, and that is how and what is going on under the hood of our item, LLM, AI, whatever the case may be. We only know how to program it and talk to it through code. But when we understand far beyond what code is, what our hardware is and how it talks, how it communicates. Once we get down to the nitty gritty of If you want to say a PCB board is the zygote of a computer, once we get to the zygote and we understand what the zygote is and how it formulates and creates all of these binary responses to communicate with other parts of its hardware, that's when we will understand computer technology. But until then, we understand how to code it and we understand that it's here for us to use. The fearful part about it is we think we know more than we're giving off. It's like the parents, man. At this point, I don't know who's smarter, the tech or us. Regardless, someone's getting played. Like, comment, and subscribe. The AI grid. Love your vids, man. Keep on bringing it, and I'll see you in the next one.